you should be able to see the Unity window, right? Is that correct? Okay, so I've taken the liberty, I know it may look like I've done a lot, but all I've done is add 3D objects into my scene. So like cubes, there's two circles and stuff like that, right? So this was a little bit of faff to get going, so I didn't want to do it all now. But you know how we've been doing this before, just like right click, create new cube, and then you could move it around, right? So you just like, you would move it around, you can rescale it, all those things, right? So that's all I did with this. Made two planes, a ball, which will be our AI for today, a little ramp up here, which is like, again, just a cube and a square, nothing hectic. Okay, so I'm sure you're familiar with doing that type of thing. Cool. So nav meshes, now it's basically like a carpet that gets laid on top of like 3D objects in our world, and it indicates locations where AI, these special AI agents called nav mesh agents, can move around on. So they could move around on this like carpet or this mat, whatever you want to call it, and it's generated behind the scenes. You don't have to really worry about it too much, but it basically generates lots of these interconnected polygons that form this mesh. So a polygon, you can think of it as like a triangle in this case. So lots of these interconnected like triangles and squares that can be utilized for mapping between different objects. So what I mean by that is, say I have like an object in the position here, like the circle. It then, through the usage of this map or this mat or carpet or whatever you want to call it, I can understand the distance or the relationship between, say, the ball over here versus, say, if the ball was over here. Yeah. So what this actually looks like, you'll have if you see on the inspector, there's a navigation pane or panel. If it's not here, I think if you go Window, AI, then you can click this and it should pop it up. But that's how you can find it. And this basically handles everything to do with generating our navigation mesh. And there are multiple ways of doing this. You can either do it before runtime or during runtime. So the one is more of like a hard generated type approach, and the other one maybe has dynamic elements involved, where if you maybe procedurally generate a world, you would have to procedurally generate this navigation mesh as well, right? But in our case for today, we're going to do it before runtime, and it's going to be like a static mesh. Okay, so now under the bake button, that's when you actually tell the system to generate nav mesh, and you just simply click bake. And what will that will do, it will take all the geometry we have in our scene, and it will create this mesh that I've been talking about. And it will be dependent on these different parameters here. Agent radius, so this is like how wide an agent you want an agent to be, the height of the agent, the max slope an agent can climb, as well as the step height if you're having steps instead of slopes, so actual like physical stairs, the max step height, as well as some other ones, jump distance, stuff like that. So what I'm going to do now is I'm going to press bake, and we're going to see what happens. Cool. Well, nothing actually happened, and that's exactly what we want to happen. And the reason for that is we haven't defined any objects to be navigation or navigable objects. So if I go to my object tab here and then click on an actual object, I can then select navigation static. So if I'm doing this before runtime, I have to make these objects static. Now there is a way of doing it without doing it like this, but for this tutorial I'm just going to use this navigation static checkbox. So I click that, and I define what type of area it is. So I'm just going to say it's the walkable area, and you can see I've done that for this plane here only. So now if I go bake, I can press bake, and you can see now there's this blue like rectangle being displayed. Okay, and that is representing our navigable area. So the area on my plane that I as an object or an agent can navigate on. So if I have, say, my ball here and I wanted to navigate to this point here where my cursor is, it can do that because it's on this navigation plane, and it handles all the direction and movement stuff behind the scenes for us, like which do I go straight across and down, do I go down and right, do I avoid objects, etc. Now, okay, then an additional thing here, you can see it doesn't come to the very edge, and the reason for that is based on our parameters that we define. Now, if I make my radius bigger here, you can see the cylinders become a lot bigger, and I bake again, you can see now that our navigation area is a lot smaller. And that's basically saying, well, if we have an agent of this hypothetical value 1 in terms of its radius, it can only move in this region here because it would be too big if it moved in this other region. It's assuming that my agent is going to be too big to actually move along here. It would actually fall off. Does that make sense? So if I make this even bigger, now we're saying that our agent is too large for this this plane, so there's actually no navigable area for an agent that big or that size. So you just play around with these and you get what you want. Okay, so we've baked a navigation mesh, but one thing you can notice is that the blue here goes completely flush up until my this like cube. And actually, if we had to move an agent between, say, this position here and this position here, it would actually just try go through this block. And that's also because this cube here hasn't been defined as a navigation object either, so it doesn't consider it when generating our mesh. So what I'm going to do now is make this navigation static, as well as these two over here, and then I'm going to bake. Okay, so now I've baked that, and now you can see something pretty cool. So now you can see that there's an edge around this cube. Okay, there's also some edges around this cube as well as the ramp, and there's also this blue part feeding up the ramp. So what's nice about this now is, because of the current settings that we have, our ball could actually navigate up this ramp and up to the top here. Alright, if it were able to get on top of this cube, it could navigate in this region as well, but you can see there's no way of moving from this one mesh to another mesh, so it can't actually get there. That should also make sense to you guys. Okay, so how is this ramp working? Well, it's also dependent on our variables. So if I decrease that max, or sorry, if I increase that max slope, right, because this is basically a slope what we got here. If I increase that slope, okay, it's fine, because this slope, I'm not sure exactly what the angle is, but it is less than 57.8 degrees. But if I make it really low, like 2.5 degrees, now my navigation mesh doesn't actually go all the way up because the slope is too high. This slope here, defined by this object, is too high for the settings that we have defined for our baking process. So I'll just increase it again a little bit. Cool. Now also, if I have to increase, or another thing you can notice here, which is related to another one of the settings, is that you see my agent can't navigate underneath this object. Right? You see how the blue is not going all the way underneath it, and that is based on my agent height parameter. So if I make this like really small, I think it will work then. Yeah. So you can see now if we have a really short agent, hypothetically you would assume that it could walk under here. So that's why we have this agent height setting as well, to avoid issues like this. But our ball is quite big, so it would never fit under there, so I'm just going to make it a little bit bigger. Okay, so you can see how you play around with these settings to work in relation to maybe the size of your objects, your balls for instance, or like a player character. And all of these settings basically have an impact of the final mesh that gets generated. And also, if it doesn't appear this blue mesh, it might be just one of your settings have displayed it so that it doesn't appear. And you can toggle it on and off. Okay, so now what we're going to do is work with the agents a little bit. So we've baked our nav mesh. Firstly we created some world that had objects. We baked an nav mesh. We made these objects static so that it would actually work. And now we're going to work on an agent. So I'm going to use this ball as our agent. I'm just going to make a quick material for it so it stands out a bit. Go back to inspector. I'm going to make it red. And I'm going to drag it and drop onto the ball. Okay, and now this ball is going to form part of our AI, well, you know, AI controlled enemy or whatever you want to use it for. So when I created this, I added a sphere collider as well as a rigid body. So you remember, rigid body means that it is affected by physics. And the one thing we have to add now is to do with our navigation mesh, and it's called a nav mesh agent. Okay. And this has a couple things that you can see. It has like some speed stats, some like turning rate stats, acceleration, stopping distance, all of these things which you can set. But we're not really going to touch any of these. These are just like some hyperparameters that you can tune to exhibit the behavior you want. What we're going to do now is basically add a function that tells our agent to move to a target, because that's basically all that we need our nav mesh to do in this case. So I've already created the script, but how you would do this is just Google. So there's all those music searches that I had for you guys. How to move a nav mesh object to a target. And a lot of tutorials tell you nav mesh agent to move to a target. That looks good. Cool. So it says that there's a move destination function that we can maybe use, and it has a transform. Okay, so we remember the transform is that game object, or game component, sorry, that gives us our X, Y, and Z, and our rotation and our scale. So we see we need to get one of those as our target or our goal. And then we need to get the nav mesh agent component. Okay, that's pretty easy. And then we use this destination function. So we say agent.destination equals goal.position. Cool. That's, what, 3 lines of code. That's super easy to implement, right? So that's what I have done. So I made a move to script. And while that opens, you can actually see it over here. I should have opened this beforehand. Sorry about that. Okay, it didn't take too long. I say before it completely finishes opening. Okay, well, while that's busy, okay, I can't actually do anything here, so we'll just wait patiently. Everyone okay so far? Pretty easy, right? You just press a few buttons, add a few components, not too hard. Yeah, definitely. The code, easy as well. So it makes things super easy to add and implement as well. So here I've made a move to script, alright, and I gave it a transform, and I've done it exactly how I've done it in previous weeks, but I wanted to demonstrate that you could use public instead of saying serialized field. I've defined a nav mesh agent component, called it agent, and I basically copy pasted that code that you saw there. Now they said to just do it on the start, but I added it on update because your goal position might change over time. So by including it in the update, you'll actually move to the updated position every time. For the examples I'm going to be doing today, it's not necessary to put it in update, but I'm sure you guys understand why this can be useful. The only other thing that you might have missed, so if I go back here, is that it doesn't actually mention it, is that you need to say using Unity Engine, and then you can add the .ai component. So you see here I've got Unity Engine.ai, and once you've added this component, you'll see that these types will change color to be like a significant type like we've seen before. But yeah, so this is the whole script, does all the pathing, and what's really cool is that this destination will tell the agents to move the shortest path to our target. And it uses the A-star algorithm, and it's all handled behind the scenes, so you don't have to implement A-star or anything like that. Cool. So what do? Well, we just attach that script to our ball. Okay. And remember, it requires a transform. So I'm going to just cheat here and make a transform. Create empty. Just created an empty game object. I'm going to call it target. And you can see this empty game object has a transform on it, so that's really why I'm using it. And I can't actually see, it's over here. And you know what, I'm actually going to add a sprite renderer to it, just so you can see it a little bit better. Circle, it's fine. Make it blue. Okay, so if I would actually use this and rotate it, yeah, okay. Okay, so here is a game object that has a transform on it, and I'm just going to drag and drop that into, I can't see it, into my script. So you see our script has a goal, and it requires a transform. I'm going to take that, alright. Now this could be like another AI, like maybe this is the player's transform. So then your AI will always move to the player, or do some sort of behavior like that. But this is just for an example, right? This little circle thing here. Okay, so now in hopes, what will happen is that the ball, when I run the game, will move to the blue circle. And all you have to do is make sure that this transform is relatively close to an actual mesh. So it doesn't have to be like perfectly sitting on the mesh itself, it just has to be somewhere in the neighborhood. And it will find like the nearest point to that actual transform. Cool, so let's run. Hopefully I haven't forgotten anything. And there you go. So what you can note is that you see it's trying to go up over here, and well, that's perfectly valid in terms of our mesh, right? It's telling it to go here. But because of maybe the size of the object, how heavy it is in terms of its mass, it's actually preventing it from moving there. So what you can do is, if I can make mass something really small, and that will work. No. Oh, okay. Another thing you could do is just remove its collider. as a way of getting around it, or you can fix your mesh. So there you go. So now it's not actually like rubbing up against that. Or you could, like I say, fix the mesh so that it's more tuned to this game object. So maybe we need to make it so that it's got a bigger radius and stuff like that. But if I run it here, you can see how, sorry, let me run it without maximizing. Put the mesh itself on. But you see it moves basically what we wanted, right? Which is super cool. And now if I move my game object like there, and I press play, you can see, although you remember I kind of place it nicely on top here, this game object, this transforms obviously way above the mesh, but it still moves to relative to where we want, right? Because it's finding the closest point on our mesh that corresponds with that transform that it's been given as its target. Cool. So that's all super useful. But there's more, for lack of a better word. So what we're going to do now is incorporate what is called nav mesh links. And the idea behind a link is, well, how can I move from one nav mesh, so like this one, to say another one? How can I move between these two? And this is, if you think in terms of a game sense, like what if there's a river and I want to jump from one like platform to another platform? Well, you can use nav meshes to do that as well. And the astute of you might have seen that there's these little arrow things here that are already being generated. And those are those links, but I'll show you how to implement them. I was supposed to remove them beforehand. So I've got links here. So let me just remove these, and we'll start from scratch. Okay, but first, before I do that, I just want to make these navigation static as well. So go to navigation, go to objects, click on the object, navigation static, navigation static, navigation static. Okay. Well, now what I want to do is I want to move from this this plane to this plane. Now you could go through this plane, but I think for this tutorial it's not necessary because I'm going to be doing some more link stuff over here. So I'm just going to go from this plane to this plane, and I want my ball to move from here to on top of this like sphere thing. But before that, I'm going to bake my nav mesh in, and you can see now that all of these other things have got our little blue like mat on top of them. This one's a bit strange because it's not connected. So what I can do for that is increase my slope that's allowed, because the slope is probably too steep, and bake it, and now we've got like a nice smooth dome that I can traverse over. I don't know why sometimes it's like glitchy in terms of the mesh itself, but that might just be like a visualization thing. So I wouldn't worry too much about that. Okay. So now what I'm going to do is try to link these two. And to do that, I need to define, obviously, a linker. So I'm going to go to the inspector, click on the objects I want to move from. So this is, I want to move from this one to this one, so I need to click on this one. And then go nav mesh link. It should be link. Okay, maybe if I just type link. Off mesh link, sorry, off mesh link, not nav mesh link. Click it. And now this component has a link on it, but I need to define this link. So I see here that it requires to transform a start and an end. Cool, well that's pretty easy. So what I can do is I've defined some random game objects around here. So I'm just gonna, so I did this one exactly like I did this square, this little blue circle thing here. Where is it? It's this one. Why can't you? Oh, okay, you can see it. Maybe I'll just bring it up a little bit. It's a little dot there. I'm going to duplicate this game object and move it to the right. Okay. I'm going to call it P1, just so I can click it quicker. And this one's P2. And I'm going to move it there. Didn't need to click it that much. I'm going to move it so that they're next to each other in the hierarchy. Not necessary, of course. Okay, now I'm just going to drag and drop those objects onto my transform here. So P1, boom. P2, boom. Okay. Now I'm going to move my target game object just over here. Okay, and now I'm going to just also move this so it looks a bit better when I play it. So now we're going to see something pretty cool. You can see there's that arrow and it traverses over that and then goes to my position on top of the dome. Pretty awesome. Now what you can do is when this is occurring you can play a special animation. So maybe a jump animation. And there's a lot of other little things you can fill around with on this. So you can make it one directional or bi-directional. And you can add a cost to going along this jump. Okay. So again, pretty easy, right? So how can I move from one nav mesh to another, like two separate ones? Well, I can create a link between the two, right? Very easy. And you can see that little link that is defined by this arrow as well as the circles which correspond to kind of those points that I generated. Now I could have defined a link to up here and then a link from here to down here to do the same thing, but like I said, I'm not going to do that today. Cool. So the last part that I want to show you is using different area costs. So those of you who are familiar with A-star or maybe Dijkstra's algorithm or like a uniform cost search or something like that, it utilizes what we call a metric, some sort of like a hybrid distance metric. So it's not just distance, but it's also distance plus like a cost. Right? So the shortest distance between, say, this red circle and the ball is obviously like the straight line distance. But maybe there's something like in the way of this path, like an obstacle or something that would hypothetically cost more for me to move along there. Well, this idea of costs is something we can incorporate into our nav meshes as well. And that's what I'm going to do here. So I have made 5 cubes, and one of them both of them actually I'm going to define as 2 different areas. I'm going to assign different costs to these areas. So how I do that is I go to navigation and I go to areas. So I just click there and then click here. And now I have all these options to pick from. Now there are 3 built-in ones. Walkable, which is blue, so that's what you've been seeing here. Not walkable, I haven't really had any cases of those. And jump. Now jump could be associated with an area specifically where you only can jump or something like that. It's up to you. So I'm going to define my own ones. I'm going to call this one quick. I'm going to give it a cost of 2. And this one's going to be called slow. And I'm going to give it a cost of 5. So how these costs work is that a higher cost is obviously less beneficial to go that way. So if you are an agent walking through mud, you would assume that that would have a higher cost associated with that than, say, walking on just like a tarred surface. So quick has a lower cost because we want that one to be like the quicker path or the quicker surface or terrain, and slow, the slow terrain like mud or something like that with the higher cost. And now I'm going to define these objects with those area costs. So if I go to navigation and I go to object, I make this one static and this one I want it to be quick. This one static, also quick. This one static and slow. This one static as well as slow. And this one just walkable. So now what I'm going to do is I'm going to add links to like hop across these platforms. So we want to click here, and once again we're going to add another off mesh link, and there will be two, one to go this way, one to go the other way. And I have generated these game objects. Yeah, so I want this one, so it's 10, 11, 10, 11. Yeah. What am I doing? Click on this. This one needs to be 10. Okay. And then the next one is 11. The start. 10, 11. Now where are they corresponding ones? Looks like 4 is one. 4 and 5. Okay. So click back on this one. Now I'm going to add 4 next to the top one. And 5 to the bottom one. So if we go to navigation, I think these are working. I have to find a link from here to here, and a link from here to here. I hope anyway. Now the next we're going to add a link onto this guy. And I think I'm just going to do it with these because everything else is getting in the way. Cool. And this one is going to be the start. Duplicate it again. This is going to be the end. And then I'm going to duplicate this one, move it down, duplicate this one, move it down. And that's what I did with all these, but I should have named them so I can remember them better. Okay, so now we're going to do the link for this one as well. So it's going to be 3 and 4. So if I go to navigation, I can see that there are arrows going there, so those are correctly done. Now I just need to do this one and this one. So once again, another link. And I'm going to duplicate this one again. Make that the start. Duplicate it again. Make that the end. So it's 5 goes here, 6 goes there. And just 2 more times more. Shift that one down. Add the off mesh link component and assign it the transforms. Cool. I didn't put the dots for those ones, but you guys know they're there. So I go back to navigation, and there's obviously no navigation on these because I haven't baked that in yet. So I can press bake, and boom. So now you can see that they're also the different colors, right? Because I assigned them the different area. And you can see the quick area is this pinkish color. The slow area is this greeny color. And then this was just the walkable, so it's blue. Okay, so now if everything works correctly, if I move my, where is it? Target. If I select my target to be on the blue area somewhere in the middle, kind of in the middle I guess, we want it to move along the quick path, right? So we would hopefully like to see that the agent comes here and chooses the quicker path to go. if I've done this all correctly. Cool. And we can see that this works by simply saying, okay, well the quick one, I'm going to make this like 15. Now it's larger than the slow. And if I run it again, now the slow one's obviously quicker because it has the lower cost, right? Boom. Let me just put this back to, what was it, 2. And that's that. So this is how you can use navigation meshes to really simplify the AI design process in terms of like movement, right? Now if you remember back to last week, we just told the cat ball to move to the player. But something you might have noticed is, say the player was here on this side of the cube and the cat was on this side of the cube, all the cat would try to do would be to try and move into this cube, right? And it would be blocked. But now with this approach, it would move around the cube to the player. And what's really cool is that intelligence, or whatever you want to call it, you don't have to program. It's being done for you. You don't have to do any sort of obstacle avoidance or path planning, anything like that. You just define this mesh. You define a very simple move to function, and you give it a target, and that's all you need to do. I suppose there is a bit more effort in terms of work in the inspector, in terms of setting up like the links and these meshes with the different costs, but I don't think that's too hard. Now, I think later on we will look at doing this in a dynamic approach. So we'll make a procedurally generated world that has a navigation mesh baked into it, so that we can still use like these cool agents. And that's in general how actual games work. A little while ago I showed you, I always forget the name, with the robotic dinosaurs, but I demonstrated that they have exactly the same thing with their navigation mesh, right? They had that blue like carpet or map laid onto their environment so that their AI could walk around it pretty easily. Cool. What is that? It's event? Door? I don't know. Anyway, that is it for today's tutorial. If there are any questions, please let me know now. Cool. So can you edit like the path planning algorithm, you say? I'm not too sure. There might be additional like plug-ins that you could download that allow you to manipulate it, but I haven't really discovered that yet. There might be stuff to do with these parameters that you could also tune as well, but yeah, I'm not too sure. Yeah, sorry, I can't really say any more than that. But for our basic games, there shouldn't be the necessity to change that. But when we start dealing with stuff like the dynamically generated stuff, maybe that will be discovered then. Yeah. Any other questions? Cool. So the task for today is to basically take last week's cat and mouse game, and instead of our very naive move to cat behavior, I want you to implement the cat's AI with a navigation mesh. The target obviously being the mouse's position, not the cursor, but the actual mouse. Yeah, relatively easy. We only had one plane. Everything else would be an obstacle, and then you just use the code that we basically used today. Cool. But yeah, so that is it for the tutorial.